Let's take a moment to remember our arc length. We remember that the arc length S is going to be equal to the radius r times the inscribed angle theta. Now if we look at a special circle called the unit circle, and the unit circle gets its name because its radius is 1 unit. So in other words, the equation for this circle is x squared plus y squared equals 1. In this case, where the r is 1, we end up with a special situation where s equals theta. Or sometimes, now that we're talking about real numbers, you might see it written as t equals theta. What this allows for us, because this outside distance is a number and the inside distance is an angle, it allows us to think of our sine and cosine and trig functions of just regular old numbers without saying, oh, this is an angle. We can now take sine of any number we want to by thinking of it as a length rather than as an angle. What does this do for us? It gives us a new way of considering our trig functions, and that is the trig functions of the unit circle. To go into this, let's recall our trig functions for a general angle through some point. Sine theta is y over r, cosine theta is x over r. We used a and b earlier, but I think x and y help us to see that a little more clearly where the values come from. Now on a unit circle, because the radius is 1, that means the distance from any point to the origin is also 1. That changes our functions a little bit in their definitions. It simplifies them. So sine theta instead of y over r just becomes sine theta equals plain old y. Cosine theta instead of being x over r will be just plain old x. Tangent and cotangent are unchanged. Cosecant and secant become cosecant theta is the reciprocal of y, 1 over y, and secant theta is 1 over x. And with all of these definitions, we are assuming that if x is in the denominator, x is not 0, and also if y is in the denominator, y is not 0. If x or y is 0, that means we're on one of the axes. It'll be these 4 points here. And in those cases, we just say that certain trig functions are undefined. Sometimes you'll see a unit circle with numbers such as cosine theta, comma, sine theta. That helps you remember that the cosine is the x value, sine is the y value. If you're at a point on the unit circle, in this case, this is about pi over 3. And cosine is going to be, well, you know, I told you to memorize them, but sometimes we have trouble. But if I look at this, I know one of them is going to be 1/2, and one of them is going to be the square root of 3 over 2. That's the case for both pi over 6 and pi over 3. Which is which? If you consider it, you're going to go a lesser distance for your x value. So that's going to be the 1/2. And you're going to have a greater distance for your y value. So that'll be the square root of 3 over 2. That's a way to help you remember these values. Likewise, if you're looking at pi over 6, the greater distance will be the square root of 3 over 2, and the lesser distance will be 1/2. This not only describes the point on the unit circle where the terminal side crosses, but it also tells us what cosine and sine are. That should be a 2. It didn't draw well. Okay, I've modified our formulas now in the background to show the unit circle formulas. In other words, I took the radius out because the radius is 1. What if we are given a point on the unit circle, p equals negative square root of 21 over 5, comma 2/5? Now where is this point? X value is negative, so it's somewhere in the left side of the grid, and the y value is positive, so it's somewhere here in the second quadrant. I'm not sure exactly where it is, but it's somewhere over there. So we have some angle corresponding to this point, some theta, with a corresponding real number t. Again, that is the same number as theta because the radius is 1. Our question is, what are the sine, cosine, all of our trig function values for this angle theta, or for this real number t? As we know, sine of theta will just be the y value, so it'll be 2/5. Cosine of theta will be the x value, which is negative square root of 21 over 5. Tangent theta will be sine over cosine, 2/5 divided by negative square root of 21 over 5, which when we invert and multiply becomes negative 2 over the square root of 21, which is negative 2 square root of 21 over 21. Our reciprocal functions, cosecant theta is equal to 5/2. Secant theta becomes 5 over negative square root of 21, which is negative 5 square root of 21 over 21 once we've rationalized our denominator. And finally, cotangent theta is going to be the reciprocal of negative 2 over the square root of 21, which is negative square root of 21 over 2.